Okay, Chapter 2, Creating and Modifying Database Tables. I'm going to put together two videos, and the first will explain just a little bit about the parts of developing a table, and then the second will actually create some tables using scripts, and then so I think that will probably show you what we need, or what you need to know to be successful in this chapter. A third video is actually going to show you kind of how I think you should probably complete homework assignments for this chapter. So getting started here, we're going to use structured query language. It's SQL. It consists of about 30 commands and enables users to create database objects, manipulate and view data. So basically it's just a language where we'll be able to set up a database and look at the contents and insert data into the database. A couple of different kinds, and I'm going to be fairly brief here, because we will talk about this in class as well. But there's a couple of different kinds of basic SQL categories or command sets. One is DDL, and those are commands to create a table. In some way, a DDL command will alter or change or mess with, if you will, the table structure. Okay, so it's data definition language, and that's going to change a table structure probably in some way. Now, data manipulation, as in DML, that's like inserting data, updating data, deleting data, that kind of thing. Now, keep in mind, though, there are some commands or some reserved words, and order is a good example of that. For instance, if you select some information and you order by, like last name or first name, that order by is essentially a sort. Now, order by in that case is a reserved word, or order in this case is a reserved word. So if you try to rename a table from orders to order, it's not going to work because it's a reserved word. And so there are a number of reserved words like create, select, order, by, and so on and so forth that are reserved words. So just keep that in mind. I think question 5 question 4 or 5 has some issue and doesn't state the problem as correctly as it should. Okay, next slide. I'm going to bounce around here a little bit. And not bounce around, but I'm just going to move quickly. With tables, that's essentially a table that houses data. Okay. Now, there are constraints. There are two different kinds of constraints: integrity constraints and value constraints. Now, integrity constraints are the actual pieces that tie one table to another, the primary key and the foreign key. So those are integrity constraints, again, tying one key or one table to another via primary to foreign key. Now, value constraints are restrictions on data values. So a good example is what you see below. When you have a data field that is for specifically students and their classes, their grade levels, sophomore, freshman, senior, junior, probably, you don't want a user to be able to enter any more information than simply SO for sophomore or FR for freshman. Those are restrictions on data values, and those are basically check conditions. For a state, you have one of 51 or 2 choices maybe, including Puerto Rico. So you don't want a user to be able to enter any more information in than will match one of those states. And sure, somebody could select the wrong, could select MN for Montana accidentally, but that will decrease the number of possible problems. Okay, there are different data types that you're going to use within Oracle and within databases. So there are character data types, number data types, date and time, and we'll use date, not necessarily time, and then large object data types. And then we'll have to, and all data will fit into one of those 4 categories. Okay, now the first data type we'll look at are character data types. Varchar 2 is a variable length character data. So by default it's a 4,000 byte max. But what you're doing in this case is setting up a column name and then what data type is it of varchar 2, and 30 is the length, the max size of that field. There you go, max size. Now, what that means is that field is 30 characters wide, but Scott, for instance, is only 5 characters. So it's only going to use in the database only 5 characters. Okay, so that makes it more efficient. It's flexible in that it can go up to 30 characters, but it's also flexible in that it'll only use 5 characters, given Scott as the example, as in that database. Now, char, on the other hand, is a fixed length character data, and there's a 2,000 byte max on that, and that looks like column name, as in C state, and then char 2. Now that max size is 2 in this example. What that means is that that data sitting in that database there will be 2 spaces taken for that particular column, whether there's any data in that or not. Now, if we think about this last name, and if we used a char 30 instead of varchar, that last name field would always take 30 spaces in the database. Now, when you think about Scott, that would leave 25 spaces unused, unused but taken. So you want to be able to use varchar 2 when that data is going to be a little bit flexible in size, and you want to use a char when it's going to be a set number. And that set number, of course, like a middle initial, is 1. States, 2 characters. Okay, so difference between varchar 2 and char. You can use a number, and a good example is zip code number 5. Zip code really isn't that great of an example, though, because you want to make a field a number only if it's going to be calculated in some way, like an inventory price, for instance, or a quantity on hand, that kind of thing, or a primary key, as in 1, 2, 3, 4, 5. That field should be a number. It doesn't have to be, but it should be a number, and any field that you're going to calculate should be numbers. So zip code is probably a field I'm not going to calculate. It should probably be probably either a char or a varchar 2. When you think about a zip code or a postal code, in Canada, for instance, it's an alphanumeric number. There's A's, B's, C's, and numbers associated with that. So, bad example, I'll change that next time. Now, if you want to a price, a good example, and it's a number, this syntax says that the whole field is 5 characters wide, and with 2 characters or 2 numbers behind to the right side of the decimal point. So this would be like 125.25. That's what that field definition is saying. Okay, date. Now what we'll really look at is a date format, and I've got some other information in chapter 3A that really defines and shows more information about how this date thing works. There's a default format to date. It's a day dash MON, being the month, January, February, March, a dash YY for year. That's the default date format that Oracle uses. If you want to do something special with a date, as in enter the date, insert the date into the database in a certain way, you have to use a toDate function. And if you want to format the date in a certain way, a way different than that default, you have to use a toChar function. And we'll look at those later. Okay, but when we look at that, that's the default date format. And when you set up a column within Oracle, you would use birth date, for instance, as the field name, and then date. That's all you have to do is say date, and that defines that field as a date field. Timestamp we won't use. Intervals, we won't worry about that right now. And large objects, LOB data types, we won't use that within our course, but very little. So in the interest of time, I'll move on. Remember, let's go back to these constraints, and these constraints are rules that restrict data values. We have integrity constraints, which are primary keys and foreign keys. We have value constraints that kind of apply to the columns. So with that, when you see a constraint type as a primary key, that abbreviation is typically PK. Okay. Foreign key is FK, a check condition is CC. So when you're asked to put down a constraint for a particular field, and it's a primary key, if you just substitute in PK for primary key, that's absolutely correct. Not null is an NN, unique is a UK. Alright, so now I think at this point we'll conclude that. Thank you.